Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Kishore, Gopalakrishna, and Xiang about Apache Pinot and its applications for powering user-facing analytics. So Kishore, can you start by introducing yourself?
Definitely. Thank you so much, Tobias, for inviting us here. Super excited to be on this show. My name is Kishore Gopalakrishna, and I'm the CEO and co-founder of StarTree. I'm also the co-creator of Apache Pinot. Before StarTree, I was at LinkedIn for 8 years. Built a lot of distributed systems such as Espresso, Third Eye, Apache Helix, which is a cluster management framework, which helped build a lot of distributed systems. Also involved in a lot of Apache projects like Goblin, S4, Databus, and many others.
And Xiang, how about yourself?
Hi, this is Xiang, and super excited to join this. So for my background, I'm currently a co-founder at StarTree, and I'm also a co-creator of Apache Pinot project. Before StarTree, I was architect at Uber's streaming data team. So build this end-to-end streaming solution for data infrastructure. And before Uber, I was at LinkedIn to build Apache Pinot, basically.
Going back to you, Kishore, do you remember how you first got involved in the area of working on data?
Yeah, it actually goes a long way back, even before Hadoop became a thing. Back in Yahoo, I was working in this forecasting team. We needed data to do the forecasting as usual. But the funny thing that happened at that time was we were asked to fill up a form, and then we were supposed to wait for a month before the data shows up because all this data was in Oracle, and we never had access to this. So this was a time when data democratization was not even a term, and it was more like a dream for us. That's when Hadoop came in at Yahoo and everything changed. And I was so excited with this change, and I thought I would directly dive into that ecosystem. That's when I started building a lot of distributed systems. Started with Apache S4, which is a streaming system. I also worked in ad indexing and a lot of data-related work that got me excited. What really changed something for me was LinkedIn being a huge proponent of open source. So I was able to join LinkedIn very early on in their journey of going from single monolith of Oracle to building all these distributed systems such as Espresso, Kafka, etc. The first system that we built, it is a NoSQL distributed systems database. And as part of that, I also got opportunity to build Apache Helix, which is a cluster management framework. So from then, there was no turning around for me. It was all data, data, data. And I've been super excited and super fortunate to get this opportunity at LinkedIn, build a bunch of systems. So overall, for me, just the ability to have access to this data and get all these insights is super exciting and also super challenging. And I love all the challenges there. So that's kind of when I started, but I haven't really gotten out of the data management yet.
And Xiang, do you remember how you first started working with data?
Yeah, so for me, my story was pretty simple. I was just a graduate from the school, and I joined LinkedIn. So my first project was actually the Pinot project. It was like in the ads team and then building like those ads reporting things around the Pinot and for serving as customers. This project was like very challenging, and later on we got a lot more use cases on Pinot, and all those things are like super challenging, and you learned a lot from the data and from working with the engineers. Those things are pretty fun, and I actually continue my career on the data world for like past 10 years. And after I left LinkedIn and joined Uber, at Uber we actually built the entire streaming data infrastructure there. We first stabilized the Kafka infrastructure at Uber. Took a lot of time to like get things being successfully produced to Kafka for like half a year. And then we built a streaming processing infrastructure using like SAMSA and Flink. After that, the story comes to like the real-time analytics infrastructure. So we have Pinot being adopted at Uber, and we also build a lot of use cases on top of Pinot. Later on, we use Presto to provide better kind of full SQL support and joins with different data sources across like the entire Uber. And also I've been involved to like the data visualization layer, like Superset, and also like the data management layer, like metadata stores kind of things.
In terms of the Pinot project, I'm wondering if you can describe a bit about what it is and some of the story behind how it came to be and why it was necessary and why you've decided that this is something that you wanted to spend your time and focus on in the form of StarTree.
So just a brief intro in terms of what is Apache Pinot. So it's a real-time OLAP data store specifically designed for interactive user-facing applications, right? I mean, that's a lot of words right there in that statement. The key aspect of these applications, user-facing applications, is that they demand very, very low latency, even at high throughput, right? Another way that people internally at LinkedIn used to describe Pinot as was queryable Kafka. So you can pretty much point Pinot to any stream and then you can start querying. That's the right way you can think of what Pinot is. And in terms of how this happened at LinkedIn, was actually a very exciting story. There are two parts to that. The first part is like when what we call as Pinot 1.0. In fact, I was not even part of that project. It was really Xiang who built the first version of Pinot, which was really built on top of Lucene, right? And we had an internal framework called Bobo and Sensei, which was also built on Lucene. And that's what we used to power some of our initial versions of Who Viewed My Profile. If you're familiar with that product on LinkedIn, where you go to your profile, Who Viewed My Profile page, and you get to know everyone that viewed your profile and where did they come from, which company, what is the skill set. And this was a very important application for LinkedIn, because what happened 2011, 2012 is many would come to LinkedIn only for when they're changing their job. It was not really the vibrant social network that it is today, right? And that was super important for LinkedIn to change that paradigm, and then where the engagement had to increase drastically. So what this app, Who Viewed My Profile, allowed LinkedIn to do was a lot of people would come to this page, know who are actually looking at their profile, and then a lot of connections and invites would actually originate from this page. So it's a very, very important thing for LinkedIn that changed the whole dynamics of how many people came to LinkedIn, and the professional network that LinkedIn is today wouldn't be possible without this app. Yeah, so the engagement metric had to increase a lot for LinkedIn. And this is when Who Viewed My Profile was built as one of the first applications to change that. And we were like super surprised with the success of this application. At any given time, there were like some thousands of people looking at this application, right? And the first version that we built was really not scaling. I remember when I joined the Pinot team, we had almost 1,000 nodes serving just Who Viewed My Profile. And it was crazy to operate this because it was not built to operate at that scale. And we were expecting less than 100 millisecond latency. So we used to break it up into vertical shards. We had like multiple clusters to just serve one application. It was a huge challenge, and it was a nightmare, to be honest, for all of us at LinkedIn. In fact, we were internally joking that we should just kill this product, go back to batch mode, and just show static graphs to the end users. But the metrics really told a very different story. right? In terms of the engagements, the metrics and the number of people actually coming back to LinkedIn was really, really high. And that got the product management super excited. And they said, hey, we need to build a new system that can actually handle this scale. And that's where we built Pinot from scratch. And we learned a lot from these issues that we had seen with the Pinot 1.0. Once we rebuilt it, the 1,000 nodes came down to like 75 nodes. And by when it actually, along with that change, the traffic had grown to 5x. So overall, we saw almost like 45x improvement in the efficiency. And that was really the game changer for LinkedIn as well. So what happened after that was every entity on LinkedIn, call it a post that you put it on LinkedIn or a jobs or an ad or even a company profile, any entity had events associated with that. And those events would flow into Kafka and Pinot would point at those events and there would be an app built on top of it. So there are tons of apps, like almost 70 to 100 apps on LinkedIn that you see today. And they're all being powered by Pinot in the backend. So any number that you see, any chart, most likely coming from Pinot. And today, if I remember the numbers correctly, it's serving around 200,000 queries per second. This is really, really great achievement for us in terms of what we were able to do with Pinot and how we changed the whole way of thinking about data at LinkedIn. And pretty much it became a de facto thing. Any page, any entity that LinkedIn created, analytics came as along with it by default. So that's kind of how we started and where we are now today with Pinot at LinkedIn.
You mentioned that the primary focus of Pinot has been around these user-facing analytics, for instance, with LinkedIn being able to see, who viewed your profile graph. And I'm curious, what are some of the alternative approaches that people may have used for being able to power these user-facing analytical use cases and some of the capabilities that Pinot provides that make it stand out as a method for being able to power these experiences?
There are multiple technologies that were used before Pinot, right? I think one of the things that really changed at LinkedIn was we were providing these analytics to hundreds of millions of members and being able to also keep the latency very, very low because, as you know, users, they don't have the same patience as the external users. They don't have the same patience as the internal analyst or the product managers within the company. So there was a huge difference in terms of the expectations from an external user facing versus internal users. And the classic alternatives were, as I said, Elasticsearch was something, and we in fact use that. There are also key value stores that people use it where they pre-compute everything, but that has the curse of dimensionality, right? As you add more dimensions, the storage explodes and they are not able, and there is also a lot of inflexibility in the query patterns when you use a key value store. So those were some of the things. I think the key change, even though it was user-facing analytics, what really changed at LinkedIn for us was this notion of building data products, right? And if you look at existing tools, they always, existing technologies, the way people consumed insights from them were through SQL editors or internal dashboards, right? And that never will generate the level of query that you can generate through an app. Like if you look at all the apps on LinkedIn or on Uber, no one knows that they're actually running a query behind the scene. So it is really a simple click is running a query behind the scenes. So our motto and our philosophy at LinkedIn was really all these reports, custom reports that we were generating, can we actually convert them into data products? I'll give you an example here. One of the products that LinkedIn had was Talent Insights, right? Which is simply providing insights on how many people moved from one company to another company. So you can think of it from Amazon. They can think, hey, there are so many people moving out of Amazon. Where did they go to? Did they go to Google? Did they go to Facebook? Which area are we losing people? Which skill sets we need to improve on? So there are a lot of these insights. And before Pinot, the way this was delivered to the users was someone internally would generate a report every month and then send it out, right? And then there were only few questions that these reports could answer. And every time they needed some change, again, there would be an interaction between the Amazon folks and the LinkedIn folks, and then someone had to write a Spark job or a Hadoop job to generate these reports and send it back. Now, fast forward a few years, now you have a talent insights as a product on LinkedIn, right? Where the entire data is just every profile change is just simply fed into Pinot. And the customers can now come in and then they can ask the questions. And then right there, you are able to slice and dice and then generate insights that you want. And there is no middle person involved in it, right? It's a huge change in the way things are seen, both from LinkedIn's perspective and also the amount of power given to the consumers. So that's the whole idea in terms of the primary use cases that motivated us to build Pinot, and we capitalized heavily on that. And it's really amazing to see all these different products using Pinot as the backend.
So as far as Pinot itself, it seems to sit at kind of a cross-section of technologies where, in one sense, it seems to fit in the OLAP use case that products such as ClickHouse or numerous other database engines work for, as well as sitting in this embedded end-user analytics use case, such as what CubeJS or Good Data are trying to power. And I'm wondering if you can just talk through some of the sort of juxtapositions of Pinot as compared to some of these other technologies and some of the systems that Pinot is maybe designed to work in conjunction with and is assuming in order to be able to get the best possible use out of it.
Sure. I think I'll let Xiang actually talk a little bit about Uber itself, like how Pinot evolved in Uber, especially seeing Uber is actually a three-sided marketplace. So there are a lot of cool things that happen, and then we can probably get into the different trade-offs and comparing with their OLAP systems as well.
So I just want to talk about some like Uber stories. If you think of Uber, it's actually a marketplace. If you take like Uber Eats as an example, they are like service providers. Those are like the restaurants, and then there are consumers, which are the riders to deliver your order, and there are also eaters who will order the phone app whatever things they want to eat, right? There will be a third part, which are the internal operations. They actually support all the business, and they can give coupons to the eaters if they don't want to order. So those kind of things are like form like one marketplace for Uber Eats. For Uber's usage at Pinot, we first start with this kind of city live dashboard for Uber Eats internal operations. So this was actually a dashboard that's shown every TV for like Uber Eats office. So all these operation people, they can actually look at this dashboard to see how many live orders in my city, in my area, and what are the long waiting orders that they need to take actions on those things, right? They probably need to call the riders to say like, are you in a traffic jam, or if you are waiting in the restaurant. So at the very beginning of the Uber Eats business, so this kind of dashboard has been like helped the business growth a lot to like greatly improve the customer satisfaction and improve the cost efficiency of the whole end-to-end pipeline, the workflow. Soon, we actually expand Pinot's usage to more like user-facing analytics. If you think of like service provider, like restaurants, they are also like one part of Uber Eats business. We actually want to provide them more insights on like how your business is doing, right? So hence we built something called Restaurant Manager, which is like the analytics dashboard for the Uber Eats restaurant. The restaurant's owners actually look at those dashboard and find out, oh, this is my revenue so far, and this is my projected revenue for today. And here are all my upcoming orders. Also for existing like orders, what are the reviews for every dishes, right? So they can get all these kind of insights from the dashboard. And that's actually greatly improved the restaurant engagement, because they can actually find out how their business is doing, and they can actually get the real-time feedback from like how their business is doing. Because all those things usually they won't be able to get unless you ask specifically to every customer in your restaurant, right? So this kind of experience actually improved our restaurant engagement a lot. And after that, we started some more use cases on the consumer side, on the eaters. So if you think of Uber Eats, right? So the initial Uber Eats app only shows you the restaurants nearby with some kind of heuristics to suggest like those are the restaurants you like. You probably want to order something from there. Figuring out that people may just order from those restaurants they like, and they may not pick those new restaurants, new joining restaurants, right? So we actually want to improve those kind of engagement for new restaurants and also let eaters to actually exploring more kind of restaurants. So here we actually use Pinot to build a feature called Orders Near You to power the Uber Eats home feed. So this kind of feature will actually show what are the current orders nearby you. And it's basically whatever things your neighbors are actually ordering. This kind of social experience, very unique for the eaters. This kind of thing also inspiring the food and the restaurant discovery and showing like what your neighbors are ordering. This feature is actually being quite popular when you are looking at the dishes your neighbors are actually ordering. Since this feature is actually part of the Uber Eats home feed, if you think of like how many Uber Eats users are actually being looking at their app at the lunch or dinner time, has to be like a super fast and personalized and scalable system in order to support as a backbone for this kind of system. And of course, all the geospatial features, index, those things we need to build for that. Soon, a lot of usage has been expanded to broad areas at Uber. So Uber later on allows ads system, allows like ads to be like placed at Uber app. So actually in Uber we build an ad system. You can actually do ads bidding and those kind of things at the Uber app. For this kind of system, we actually need to provide a super accurate performance and business metrics. Don't count on any kind of impression or like click events, or you don't want to miss any of this kind of events. Those things will actually make the ads customers to be like having bad experience about ads performance, and you also don't want to overcharge or mischarge your ads customers. So that we actually build the upsell feature in Pinot, along with exact ones Kafka and Flink. We actually provide the exact ones guarantee for the whole end-to-end streaming data infrastructure at Uber. That was actually pretty impressive and very hard to achieve across the industry. Of course, at Uber, there are like so many data scientists, and they actually need kind of the full SQL access to your data, and hence we are building the Presto Pinot connector, which really connect Presto to Pinot, and data science team actually use full SQL to explore all the data in Pinot, and along with like joining with their like Hive table and do more advanced algorithms and verifications, a lot of things, build models as well. So all those things are like being built across.
RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their state-of-the-art reverse ETL pipelines enable you to send enriched data to any cloud tool. Sign up for free, or just get the free t-shirt for being a listener of the Data Engineering Podcast at dataengineeringpodcast.com/rudder. One of the interesting complexities of the particular problem that Pinot is trying to solve for is because you are exposing this to end users, it needs to be able to support sort of high concurrency. And I'm wondering, what are some of the ways that influences the overall architecture of the system to be able to manage that type of workload as compared to what some of these other OLAP engines are optimized for?
Yeah, so I think one of the design principles that we had very early on, we looked at all these other OLAP systems and these databases. So the typical way most databases thought about solving these problems was, hey, we have to scan all these data, we have to do X amount of work. How can we do this work faster? You had SIMD, you had columnar stores, those were all the classic things that people adopted. But we took a very different approach because we knew that we could only push them as fast as the SSDs or the CPUs that were already available. So our philosophy was to eliminate that work instead of trying to do the work faster, right? That's where we built a ton of indexes in Pinot. So we have a wide range of indexes like sorted index. We have the bitmap index, which is the inverted index concept as well. We have the range index. We have JSON index. We have text index. We have geospatial. So there are a lot of different indexing techniques that we built, which eliminated the work that needs to be done. So we would use this index, get to the right location. So we even added a lot of enhancement in terms of rearranging the data. So even though we ingest it, while we actually write the segments, we would rearrange the data so that we get locality. So we could solve the query with one seek instead of having 100 seeks. So we did all these low level optimizations, and a lot of these happen automatically. And then last but not the least, we went beyond just the filtering and the indexing, right? And a lot of them also took a lot of time in terms of aggregation because a lot of these user facing applications needed aggregation queries. So we built powerful indexes such as StarTree index. In fact, that's one of the reasons why we named the company as well as StarTree, because it's a unique index that's not available in any of these other systems. It's something that allows you to get even scanning in billions of rows with StarTree index. You can actually get that in millisecond level latency. A lot of cool things that have happened in the indexing area within Pinot, and that kind of what makes it very, very different from these other OLAP engines. And also another principle here is that you have all these different features within Pinot, and you can use things when you want them, right? You don't have to use all of these at once. But the idea is that you have the knobs that can take you all the way from tens of QPS to thousands of QPS, right? And that's the beauty of the system. It's one system that can get you started on a project, and it can take you all the way if the project becomes very popular. So we have a lot of products at LinkedIn which started very small, but then as soon as they become popular, now you need to move that into another system. So that introduces a lot of operational overhead. Now you need to have multiple systems within the company, one for internal, one for external. That's kind of what we were able to prove at LinkedIn and Uber. And now you see that that has spread across all these other companies like Walmart, Stripe, Target, Cisco. All these companies have started doing the same thing. So it becomes one platform and you can solve both your internal and external use cases.
For those types of use cases, I'm curious how you have seen these businesses approach the question of which database engine and query engine they should be using to power these analytics, whether it's ClickHouse or Snowflake or Postgres, and then some of the different additional systems that they're going to need to be able to complement and support and integrate with the ultimate technology that they decide as sort of that core building block.
It's interesting to see the journey from the company's point of view, right? How do they look at the evolution of their analytics? So most companies, if you look at their journey, they start off with the business intelligence first. They then get into the operational analytics. So that's their evolution. And most of these tools, like a data warehouse or the OLAP tools, the prior ones were able to address these needs. But now companies are seeing the value of providing these insights to their users and their customers. And that's when they get stuck. They hit a wall and they're not able to take these existing systems. So the way we see it is you need all these different tools, right? It's not just one tool. This data warehouse is not just going to solve all the problems, but it's about how do you actually integrate these systems easily. If you look at data warehouse, that has a very different set of needs and for different personas. So you have this business analyst who write like 100-way join and then a lot of complex queries that they keep changing and they treat now. So for them, data warehouse is a perfect tool where they can actually create dashboards on top of it and then share the results. But when you look at app-based consumption, where the end user is not technically well versed in terms of writing a SQL query, for them, it is through apps. So they need to simply be able to click. They need to be context aware. They need to know what tool they're using and how to use that UX. For them, it's a very different experience. But then they end up generating a lot more queries, but the query patterns are kind of well known in advance because it's the app that's generating the query. So different purposes, different engines, and they're all made for different purposes. Just to give you an example, Snowflake across all their customers is really running one query per second, right? Whereas LinkedIn, just at LinkedIn is running at 200,000 queries. And the main reason for this is with the access pattern. So one side it's through SQL editors and dashboards, which doesn't really generate a lot of QPS. And on the other side, it is apps which end up generating tons of QPS behind the. So the workload characteristics is very different. The freshness requirement is very different. Also, the latency requirement is very different. So depending on these, you pick one system versus the other. But in the end, you need to have ability to serve all the different use cases.
Yeah, I can add something related to Uber. So at Uber, I can take the example of the orders near you feature. Actually, when we built these applications, the initial version of this kind of implementation was actually Cassandra. Cassandra is actually the data backend, like the permanent store for all the place the Uber Eats orders and all those like restaurants. So at the first iteration, we actually implemented by like first retrieve all the nearby restaurants for given user's location, right? You have the latitude and the longitude. And once you have all the nearby restaurants, you actually fetch all the active orders from another service called the order gateway service. Once you find out all those orders, then you will try to rank all those results based on the recency and merge those things and push it to the home phase. However, for this kind of application, it actually translates one users into like 100 Cassandra lookups, right? So this kind of translation will actually greatly increase the workload on Cassandra. So based on the estimation for the Cassandra team, in order to support this kind of use cases, it needs to 6 times Cassandra store, because all those kind of read workload basically need like more replications for your key-value store in order to support that. And once we move those things into Pinot, right? So if you think of like all the order status change, those kind of things go into Pinot. Pinot is also optimized for readability, right? And with the geospatial indexing support, we actually convert this kind of one user's page view into just one query inside Pinot. Also with the geospatial index, the query latency was actually dropped from, in Cassandra, it was like a couple of seconds. You actually finish this kind of 100 lookup round trip. The P99 was less than 50 milliseconds for just the one query, which means this also greatly improves the user experience in terms of when you open the Uber Eats app, you don't need to wait the app logo to spin in multiple seconds in order to see everything. You can immediately see what are the orders nearby you, right? So all those kind of user experience improvement are super critical for the product team as well. I just mentioned the cost effective for Cassandra, you need so many machines, right? And for Pinot side, these kind of use cases are just being supported with 10 regular machines. And that's also like very impressive achievement from the data team side to actually being able to provide this kind of support with a very small like hardware footprint.
Digging more into the architecture of Pinot itself, can you talk through the different components of the platform and some of the ways that you proved out some of those early design decisions and some of the elements that were key to being able to support these low latency and high concurrency queries?
So from the Pinot side, the key design principle is we want to provide a predictable query latency and high availability and scalability system for our users. So for our external clients, we need the always on system. So you don't have any luxury for downtime by saying, okay, we have a database maintenance, right? So we actually need to make sure all the replications are there. There's no single point of value of the system. So for all the layers inside the Pinot, we are using Apache Helix and Zookeeper for the cluster management and handle all those node value or the node upgrade seamlessly. Second part is like for Pinot to be like super operational friendly. So at LinkedIn, there were only 3 SREs there. At Uber, when we built the Pinot from the very beginning and until now, the Uber's Pinot team size hasn't been grown significantly. I think we only have like 3 to 5 people at Uber to support the entire Pinot cluster, and the Pinot cluster size has been grown from initially it's only 3 nodes to guarantee your applications. And now in one data center, there are more than 500 nodes to serve all Uber's use cases. And worth to mention that this kind of Pinot has been designed as like a highly configurable. So we actually want one system and one cluster for multiple use cases, right? So if you think of like at Uber, this one cluster in one region is being serving all the use cases along with the internal dashboarding, with the user-facing analytics, data scientist team to do full table scan on some kind of the tables. So we actually built in the multi-tenancy model inside the Pinot, so you can achieve all those kind of resource isolation inside the Pinot.
And for the sort of typical end-to-end use case of I have this event, it's triggered by some user using the application through to I have aggregated across this event and all similar events to be able to provide some useful insight to an end user. What are all of the different system components that are necessary for Pinot to be able to incorporate and aggregate and deliver that information to the end user, whether that's Kafka for managing the streaming event inputs through to some of the kind of UI and application development considerations for integrating with Pinot?
I would like to see this whole stack as like track. First is the tracking clients, right? You need to somehow track all the activities that is done by the user. And typically this is either a Kafka client or it's some sort of an application, an SDK that is embedded in the application itself. The second part is, as you mentioned, the collection, right? So this is where something like Kafka or Pulsar or PubSub or Event Hub, all these things come, Kinesis, all these different systems come in play. The third one is really the store plus analyze, right? And that's where something like either the data warehouse or something like Pinot comes into picture, both storing and computing. So there are different applications here. Some of them just provide the storage, they don't provide the compute. Some of them just provide the compute. Some of them provide both compute and storage. So there is a lot of different systems that are being built in just the compute and storage part. It's complex and it's also a very important piece of the tech stack. And the last but not the least is like really your visualization layer or any sort of apps that you build on top of it. So in terms of Pinot, we try to make it as simple as possible. There is an intermediate layer that I missed, which is the processing layer before it gets to the storage. So if you look at it, it's collection, and then there is a processing layer like Flink, Samza, and other ETL systems, K-Streams, or even Spark and Hadoop in the batch, right? I think there are these processing systems that just process and then put it back into the original store, be it Kafka or a data lake. So what we are doing as part of Pinot is we want to simplify the ability for any user to get started. So when we initially started Pinot, we had this need for only having structured data. So that means you needed a processing layer in between that would take the data from Kafka and convert it into a structured form and then feed it into Pinot. So of late, we are going from just having supporting the structured to even being able to support semi-structured and even getting all the way to the unstructured data as well. Now in just simply pointed Kafka, in just the complex Avro format as it is, we convert internally into JSON. We are able to add indexes on any nested complex JSON fields, and the users can actually start querying. And as they start querying, if they want to create new fields for some of the most commonly used ones, they can add derived columns on the fly. So we are trying to change the workflow from the user and also the experience where they can simply get started very fast. They don't have to worry about indexes. They don't have to worry about the ETL step in between. But as they learn, as they build more and more applications, they can create derived columns on the fly without having to re-ingest the data. They can add indexes on the fly. They can configure pre-aggregations using StarTree index. So we are trying to make it more iterative process, and this every iteration is dynamic and can be done on demand without having to rebootstrap the data. That's the way we are going about, because we don't want to have a lot of initial step for the users to actually get something out of Pinot. And the second one on the consumption side is also the need to whether you do a pre-join or you do a post-join, right? And again, this depends on the application itself. Sometimes the latency is, they have a much bigger buffer for the latency requirements. In that case, they can just ingest the data as it is, have a layer on top of it, which is Presto, that can actually do the joins across data in Pinot and also in some other data sources. Even trying to simplify that, if the data is always in Pinot, then the joins can also be pushed down into Pinot. So we are adding joins as we speak, and we had the first version of join PR go out last week. That's another capability that we are adding. So overall, we are trying to reduce the amount of pre-processing and the post-processing that is needed for someone to build applications on top of Pinot. At the same time, we have all these other knobs in case the workload requirement changes and you have a very popular product and then you need really, really low latency for the end users, you can still do it. If you want to run internal applications, you want to build applications such as anomaly detection and things like that, you can do that too. So overall, we are trying to improve the coverage, simplify the initial onboarding experience for Pinot, but at the same time, have the ability that if they want to build like really, really powerful applications, they still have the knobs to actually get there.
As far as the data modeling considerations, you mentioned that in order to be able to run joins across data that's stored in Pinot, you end up having to use Presto for being able to support that type of syntax. And so I'm wondering if you can talk through some of the ways that users of Pinot need to be thinking about the way that they lay out their data structures and data models to be able to power these user-facing analytics use cases and some of the edge cases that you've run into as you start to design and build out these systems.
Definitely. So, as I said, this was a big concern in terms of the usage of Pinot because they had to do a lot of thinking upfront because we had only structured data support, right? And that means we could only support column types of int, long, all the primitives. But now we have, with the support of JSON and being able to even index fields within a JSON structure and even unstructured, this is reducing drastically. You can defer that thinking to a later time so that you can get started very quickly. And the second, in terms of pre-join versus the post-join, this is a great thing that keeps coming up every now and then. It's just simply impossible to get the latency that you need for your user-facing analytics when you have joins during the query time. So you will be sort of forced to do the join upfront if you are going for user-facing analytics because the experience of the user is really, really critical. A lot of times we have seen companies try to avoid that join and then they try to do the join during the query time and the experience is so bad because you have this cursor spinning all the time and the experience is really bad from the user point of view. So it is worth paying that additional overhead upfront in terms of doing the joins before and then avoiding the joins during the read time. So push it. So it's really in the overall scheme, it's where do you put the join, where do you put the transformation? That is really what someone needs to think about. You can always get started with no joins, no transformation as it is. As you see the product becoming more and more successful, then you can introduce the pre-join and also the pre-transformation if needed. It's all about having that flexibility that you can change this, but you don't have to change the system itself. That's the most important thing because changing the system means that you're trying to change the whole stack. Now you need to change your clients, you need to change a bunch of things, and that is something that is not needed, that we want to avoid as much as possible.
Some add-on to from the Uber side. Initially, we actually just try to do the very simple thing. We try to dump one Kafka topic into one Pinot table. That's kind of the story when we allow user to do the self-serve Pinot onboarding. They can just say, okay, I have one Kafka topic which has schema inside and can pick some columns and then dump the data into Pinot. And then I can use Presto for joining and for exploring. Then they will figure out, okay, so for my use cases, I can serve it from the Presto side for some kind of users. And then they later on figuring out, okay, I need this kind of latency and the QPS requirements to be supported. Then they actually move this kind of Presto join or whatever the declaration queries or pre-aggregations into something like stream processing framework like Flink. And they can write stream SQL to actually create those kind of new tables, flattened tables, and then ingest that into Pinot. And in Pinot side, you can also build a sorted index or inverted index in terms of serving more user-facing analysis queries like Since those queries are like per user basis, then you can actually do more indexing and the query performance furthermore. So all those kind of are more like journey or like how a product or the data model has been built. People really, although they have the rough idea of their product, but they don't really get the data modeling first and make it right. It's always iterative. If you build the entire stack, which from the Kafka to Presto, it actually allows the product team or the application people to figuring out what they really need. And also it greatly improves the iterative time, right? So if you want to upgrade your system, add one more new feature, the turnaround time is actually much faster in terms of using this whole stack.
Are you looking for a structured and battle-tested approach for learning data engineering? Would you like to know how you can build proper data infrastructures that are built to last? Would you like to have a seasoned industry expert guide you and answer all of your questions? Join Pipeline Academy, the world's first data engineering bootcamp. Learn in small groups with like-minded professionals for 9 weeks part-time to level up in your career. The course covers the most relevant and essential data and software engineering topics that enable you to start your journey as a professional data engineer or analytics engineer. Plus, they have Ask Me Anythings with world-class guest speakers every week. The next cohort starts in April of 2022. Visit dataengineeringpodcast.com/academy today and apply now. Another interesting element of this application space is the question of the data lifecycle, where when you're working on internal analytics for an organization, you're likely going to want to keep all of the data available for querying for a fairly long time horizon. But for user-facing applications, those time horizons can be highly variable depending on context. And I'm curious how you have approached that aspect of the problem in Pinot to be able to support this sort of management of time horizon and then data tiering so that you don't necessarily have to have an all or nothing approach where maybe you just have to accept some level of latency for queries that are going further back in time.
Absolutely. No, that's a great point. As you saw, we started off with the intent of user-facing analytics where the retention span is much lower, right? I mean, we see somewhere between 30 days to 2 years, right? That's where, and the value of data also decreases drastically as they age. But one of the common things that we have been asked from the users is, hey, we love the speed of Pinot, and we also want to use it for internal analytics as well, but it is not cost effective because now we need very tightly coupled architecture. So now we need to scale the compute and the storage together. But we very infrequently query the older data. So that's one other big change that we did in Pinot. So we were able to add this concept of tiered storage. So that again, kudos to all the engineers in the Pinot team. We built it in a way that there was a right abstraction in terms of the file system API. We were able to move from the local file system to the remote file system. So now Pinot can actually run directly on S3. That changes the whole game because we have seen someone like Stripe, for example, has the transactions from day one. It's huge. They're already at like 2,000 nodes with petabyte of data, and it's already overtaken LinkedIn and Uber in terms of the scale. And something like a tiered storage is a big game changer because now you can keep the data for as long as you want, and you can tier it to the S3 or any other blob store as the data ages. It's a really big feature. And the best part about this, as with everything else, is Pinot has been designed where you can almost think about it as a slider. You can actually decide at which point in the slider that you want to be. You can have one extreme of all of them are tightly coupled, local, both the compute and storage, and the other extremes, everything is decoupled. And you can also be in between. You can say for the first 10 days, I want it to be tightly coupled. I want the data to be local. And after this data ages more than 10, it can go to the S3 tier. Those are all, again, configurable, not only at a cluster level, but you can even configure it at every table level. You can have some tables move the data after 30 days, some of them after 10 days. Again, it's the ability of not only providing you the trade-off, but also the ability to provide that control that you can decide the trade-off point. And depending on the application and depending on the requirement, you can change that. So tiered storage is one of the big things for us. We have added the support for S3. We plan to add for GCS and Azure as well very soon.
Apart from that, for data lifecycle management, Pinot side, you can also use Pinot Minion to do like aggregations or post aggregations for your real-time data as well. Because typically when you are ingesting data from Kafka, all those things are event-based. However, for your queries or your applications, a lot of users, they actually just show the aggregation results, right? So in terms of that, Pinot Minion can actually do the post aggregation after one day is finished, or the configurable time actually you can run it in an hour or in one day to aggregate all those events and generate much compact data block and then serve it in a more efficient way, which means even for the same data, you can actually many more years of the data, but with like a very low cost if your system can do this kind of aggregations later.
As far as being able to customize Pinot, you mentioned that it was designed to be flexible and adaptable to the sort of end user's requirements. I'm wondering if you can talk through some of the interfaces that are available for people to be able to extend and implement their own capabilities on top of or within Pinot.
So for the Pinot side, we basically make like every component to be like extensible or pluggable. For example, at the LinkedIn time, LinkedIn has a stack of all the batch processing in Hadoop, and LinkedIn has its built-in data format is Avro, and the real-time ingestion coming always from Kafka. So that's kind of like how the initial version of Pinot, which you only need to support this kind of system integrations. And later on, when we move to the open source, we figure out many people has like different requirements and they have different systems. So we make a lot of things to be customized. The first is definitely the encoding and the file formats. So apart from the Avro side, we also support Swift, Protobuf, and also like a Parquet or say all those kind of different file format. It's already been built in inside Pinot. Execution framework, the batch execution framework, we have the support from Hadoop, from Spark, from Flink. So all those kind of batch processing are now available from the open source side. You can actually run your Pinot segment generation job in Spark or Flink as you wish. Also for the streaming data ingestion, Pinot can actually now Pinot abstract all those kind of streaming interface, how you get data into Pinot. So from Kafka side, it's just like version upgrade. We have two Kafka interface, one for Kafka 0.9 and one for Kafka 2.0 plus. So you have two Kafka connectors, and then we later on build the Kinesis support. Also, we have the Google PubSub and Apache Parser. Recently, there are some more contribution from the community for RabbitMQ. So all those things are like all based on the clean, the right abstraction for the interface. So it makes the user easily hook up their existing system, and also they can contribute it back to the Pinot community.
And in terms of the applications of Pinot, I'm wondering what have been some of the most interesting or innovative or unexpected ways that you've seen it used?
Stripe probably was definitely the one that came to my mind, is ability to just keep the raw data forever and at the same time be able to do aggregation also on top of it using StarTree index. So now you can start at a very high level and then you can start doing root cause analysis. You can narrow down and you can get to all the way to a raw event. So that is a very interesting use case that we saw. And in terms of just the ads itself, I think there is the way people have started using the geospatial indexing and the ad tracking and the ad accounting is also another amazing thing that we saw, where ads are shown on buses and then you track the buses on one side and then you track the users on the other side, and then you are able to do the intersection between the two, and then you are now able to see how many people actually saw an ad on the bus. So that's an amazing use case that we saw. It's really cool to see how many people get inspired from things like Uber Eats. Like you can think of a website now selling cars. Now they can provide analytics to the dealers who can actually how many people viewed your car page, how many people clicked on what, and you can kind of provide all these insights back to the dealer. So there is a lot of these insights that can be provided. Just a call, for example, another cool application that we saw is the transcripts of the call that we are talking about, right? Like that can actually be fed into Pinot. You can think about like how long did Tobias talk, how long did Xiang talk about in this call, and how long did I talk, what was the tone, who said hi first, who said bye. All those things can actually be provided. It's like a lot of these things that we never thought being in a company at LinkedIn and Uber, but now it is a lot of things in terms of both B2B and also B2B2C. Trading is another application. So there is tons of things that we are actually seeing in the wild that we had definitely not thought about before. But really good to see how people draw analogies between the ones that we have already built and how they translate it to their use case. Education is another one. They're looking at the videos. They're like, okay, how long did the users watch this video? When did they pause? How many, was there any section that was watched multiple times? So again, so a lot of analytics on pretty much every entity that you can see on the web, you can basically provide analytics around that. So yeah, definitely a lot more things than than what we expected. And again, LinkedIn is a great example. We already have like 70 products on LinkedIn itself. That itself was a huge win for us in terms of seeing how quickly the adoption grew and what kind of products they were able to build.
And in terms of the kind of growth and adoption of Pinot, I know you mentioned a number of different companies that have been relying on it, but from when it first became public to where you are now, I'm wondering if you can talk to some of the ways that you're thinking about the sort of community engagement, community involvement, and areas of contribution that you're looking for.
Yeah, definitely. I remember when we started, we had a very small community. We had like a Slack channel of like 100 people in 2020, and then we were not even tracking the downloads. We had zero downloads. And fast forward 2 years, we have like more than 2,000 people in the Slack community, very vibrant, asking a lot of different, very, very exciting questions. And we get to know all the use cases that we had not thought about before. And at the same time, we had like almost a million downloads, more than a million downloads last year itself. So huge growth in the community across. Again, a lot of help from LinkedIn, Uber, and Stripe, and all these other companies getting involved in the project as well. It keeps pushing the envelope further and further. The bunch of things that we do want help from the community is extending the feature set. Uber, for example, helped us add the upsert feature, which is a big differentiator and something that a lot of other systems are not able to add. Then tiered storage is something that we from StarTree is contributing to that, towards that. So join is another one that we did. We are adding that as well. So JSON storage. So there are a lot of these things, and we actually even published the roadmap, and we also share the roadmap, and community can actually vote on that. Any members from the community are listening to this, definitely encourage them to vote on these features, because take that very seriously. That's something that we consider for the prioritization of the work that we do. Again, it's community is our product management for us. They tell us what the priority is. So really looking forward, not just from contribution, but also in terms of their requirements and where they want to take the system forward.
In your own experience of working on the Pinot project and now your work at StarTree, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think was the biggest challenging here is when we were at LinkedIn and Uber, we actually focused a lot the speed of Pinot, because for all those kind of well-established companies, you have a pretty good kind of ecosystem, which all the software foundation has been placed there. So you can leverage those. For example, how you deploy Pinot. At LinkedIn, there are like container management. At Uber, there also like have all the Docker missiles and all those things there. But when we come to StarTree and we figure out, oh, this industry are using Docker, using Kubernetes, they want to have those kind of integrations. So we actually quickly build those recipes on how you can simply deploy Pinot. You can also do things like the management, right? So at Uber and LinkedIn, we have been built a lot of toolings. Now we actually make all those toolings to be actually built in Pinot APIs, which you can easily do, let's say, table rebalance, those kind of things in Pinot itself. Another thing here is we actually transformed to make Pinot plugin model, and we actually focused more on the right abstraction of the interfaces. So Pinot itself can be easily extended to like suitable to integrate with other systems. So at the very beginning, when we built, for example, the Kafka connector, it took like a couple of months. Once we make the clean interface for that. So for Kinesis connector, the POC was done in 2 days, and it took like a week for us to really productionize it. But this kind of turnaround time are actually super impressive, and you actually realize the power of you are doing the right thing and making the right app structure, and all those pluggable model really makes the difference also for the community to contribute things into your system, and you have the right capability for like unit test, integration test, all those things.
Yeah, I think Xiang pretty much touched on a lot of different points here. Only thing that I would probably add there is kind of our thought process being at LinkedIn was always about speed. If you kind of look at the evolution of how you build a feature or a project is like make it work first and then make it right and make it fast. But at LinkedIn, we would always shoot for make it fast because that's kind of the scale at which we were operating. So speed was like really, really important for us. And I think as we see more in the open source, it's about the iteration speed is also very important. So we want to get the feature out, we get it in a good enough shape so that people can use it, but then constantly iterate on top of it. So paying more focus on the iteration speed and then taking it to the finish line in multiple steps versus trying to get to the best in the first version. I think that's something that we are being aware of and then trying to change that.
For people who are looking for a system that will provide low latency queries and potentially serve, multiple concurrent users for user-facing analytics, what are the cases where Pinot is the wrong choice and they might be better served with a different architecture or a different storage engine, or maybe reconsidering their requirements?
Yeah, definitely. I mean, the first thing is it's definitely not a replacement for data warehouse. We have seen many cases where Pinot coexists with BigQuery, Snowflake. So they have all this data in Snowflake, but it doesn't get them the speed that they want to serve external applications. So they take the data and then put it into Pinot. So that's perfectly fine. This is probably not a tool where you give it to your business analyst and then ask them to write like a super complex 100-way join query. So definitely not a replacement for data warehouse. It's also not a replacement for like your traditional key value stores. So I wouldn't, instead of using MongoDB, Cassandra, or any of these other systems, you don't want to use Pinot for that. There's no transactionality that is there. It is not really built for ACID compliance. So it's not an OLTP store in that way. Definitely not a relational database as well, like OLTP, not MySQL, Postgres. So that's not a replacement for that. And it's also not a replacement for search systems where you want ranking, relevance, like Lucene and Elasticsearch, they're the right systems. Though we are seeing a lot of workloads move from some of these systems into Pinot. And the reason is just that something like Pinot was not available. So people ended up using whatever system that they had, but they hit the scale and they hit a wall and they're not able to get what they want from this system. So we do see a lot of use cases move from Postgres, from Elasticsearch, from Snowflake data warehouses, and also even from the key value stores. A lot of them do move to Pinot, but that's because they were not the right systems to use for analytics in the first place.
As you continue to build and iterate on the Pinot project and grow the business around StarTree, what are some of the things you have planned for the near to medium term, or any projects that you're excited to dig into?
Yeah, definitely. Tiered storage is one thing that we already released a preview version of that. So now we support S3. We will plan to continue iterate a lot on that. We see that our goal is to be able to provide almost the same performance as we are able to provide with local storage. We are already seeing that it's very close with like literally like some 200 milliseconds extra latency, and we have done ton of innovations there in terms of being able to provide this performance with the tiered storage by being able to work directly on S3. So you are still getting sub-second latency with that. And the second one that we are super excited, but we'll continue to invest is going from this concept of data is immutable once you put in Pinot to being mutable. So it's not only mutable in terms of batch, but you are now able to update every single row in Pinot. Right, I think that changes a lot of things that you needed join before do not need joins anymore. You can get accurate metrics. A lot of things open up because of this ability. So that's another thing that's super excited. Last but not the least, there are data models that are structured. There are data models that are semi-structured and they're unstructured. We are taking that to an extreme where we say that you can have a table in Pinot and you can decide what each column should be. Each column can be either a structured column or a semi-structured. So you can have a table with lots of different columns and each one can be its own format. So that's another thing that we are excited about. Join is a new one, and we plan to continue to invest heavily on the Join, again, in collaboration with Uber and LinkedIn, build distributed joins, multi-stage. So we already have the first version that's already in progress in preview. And then we plan to add the co-located joins and all those other fancy things in the join side. In terms of the use cases, so one of the things that Pinot was really for the metrics use case, but we are seeing a lot more of logs and traces applications coming into Pinot. So people are using Pinot as like the strong backend, de facto backend to build their observability systems on top of it. So a lot of companies are using Pinot as that backend. So we will continue to enhance Pinot being your single store for your logs, metrics, and traces. All of them can be served in a more very efficient manner with all the features that we added so far. And last but not the least is like integration with all the other players in the ecosystem, Presto, Trino, Kafka, Pulsar, all these Spark. We want to make sure that our integration is really, really strong. As you see, the stack is quite complex right now, and we want to take a lot of burden out of the users to be able to integrate this with other systems in the wild.
Are there any other aspects of the work that you're doing at Pinot or the ways that it's applied or the specifics of its implementation that we didn't discuss yet that you'd like to cover before we close out the show?
One thing that I would like to add is really the way we see the whole tech stack play out and how it's changing. I kind of see a very strong analogy with how the monolith is splitting into microservices in the stateless system. I see a similar thing play out in the data system as well. What used to be this one giant, if you look at it decades ago, was like Oracle doing your collection, storage, analysis, visualize. It did everything in one system. And that's the thing that we are seeing that change. Now there is one system for just collecting, and which is Kafka, and there is one system just for storage. There is one system just for compute. Each one is becoming so complex and also for a good reason in terms of evolution. And I think it's a good thing to happen. I think the same thing is happening on the data warehouse side as well, where everything was solved in a data warehouse and now that is getting split apart in terms of different systems coming into picture and doing one thing really, really well. So what this is definitely a little bit of an overhead for the users because now they don't have one tool, they have hundreds of tools. Some might argue this is a bad thing, but I think it's a part of the evolution in my view. What we really need is the tooling system to make sure that these systems can integrate seamlessly. And so more standardization being evolved across all these applications will definitely help in building those tight integrations. For example, S3 is definitely one of the things that standardized on the file systems, right? And Kafka is getting there in terms of being the de facto standard in terms of the messaging API. So the more these standardizations evolve, there is a lot more ability to seamlessly integrate these different components. We are super excited about that. We continue to make sure that Pinot is super easy to integrate with other systems out there.
Well, for anybody who wants to get in touch with either of you, I'll have you each add your preferred contact information to the show notes. And as a final question, I'd like to get each of your perspectives on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I kind of covered that in the previous one. I think it's built on that. It's really that there are so many different tools out there, and it's definitely confusing for any user to know what tool should I use for what, and making it really simple for them to put these pieces together, right? I think the way I see it was previously in data, you would buy a pre-built toy, right? And you were not really building that toy. But now requirements from within the company have changed so much that just one toy is not going to serve all your purpose. So you need like a lot of different toys. But you go to the market and what you get is like Lego pieces. So you now need to put those things together to build the stack that you want. So it's very powerful because now you can build so many different toys from these Lego pieces. But at the same time, you need to know how to connect them. It's a different challenge from what used to be there before. The previous one was like you would have like 100 different systems doing one thing, and you don't have a very clean stack. So you have the same data sitting in like 100 different systems. So that was a different problem. Now you have a different problem that you can actually build an amazing stack, but putting them together is not easy and not trivial. So I think that's the gap. Again, it's part of the evolution. I think 10 years from now, it will be a very different thing where it makes it so simple and seamless, especially with the SaaS companies coming out and everything being offered as a service. You don't have to do that. It should be, there will be seamless integration between all these services so that you can actually put together a completely end-to-end stack within a day or two.
From my side, I think Kishore pretty much covered all my thoughts here. Yeah, one thing here is about more advanced kind of integrations with all the other surrounding areas apart from the reporting, dashboarding, those traditional BI use cases. Here we have more things like data scientist kind of integrations. There are a lot of data scientists, people, they are building models. They build companies to say, okay, you can run these fancy models or this machine learning platform top of different data stores. And here, since the trend of moving to real-time data is becoming more and more useful, and people realize how powerful those real-time data are. In the old time, we don't have a way to provide reliable, fast real-time data. Nowadays, this is not a dream. It's the reality. And those kind of integrations and how people are leveraging real-time data and discover this kind of gold mine is the next thing and the missing part, that you can actually leverage this real-time to do more things. And people should open up their mind, find out what are those things can actually being achieved.
All right. Well, thank you both very much for taking the time today to join me and share the work that you've been doing at Pinot and now at StarTree. It's definitely a very interesting product, interesting project, and an interesting problem space with a lot of complex requirements. So appreciate all of the time and energy that you and the rest of the community have put into that. And I hope you enjoy the rest of your day.
Thanks again, Tobias, for having us. And kudos to all the great work that you're doing. I've been listening to your podcast for a long time. It's very, very insightful. Get to learn a lot of good things. Keep up the good work. And thanks for doing this for the community.
Thanks, Tobias.
Thank you. Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.